Hello, good afternoon. Today I am going to be experimenting a bit with some volume rendering and rendering spheres. So one of the things that we've tried a bunch of times with YT to varying degrees of success, and there have been some really good efforts, has been to set it up so that you could do direct volume rendering of spherical objects. Today I'm going to see if I can help with some of the coordinate transformations that a student working on this at the University of Illinois has been working on as well. What that means is I'm going to attempt to draw a sphere composed of many different wedge objects. And so that's going to be the very first thing that I try out doing. And to do so, I am going to work within the yt-idv framework, but I'm going to be doing that through the process of writing a new script to generate block transformations and so on. So why don't we go ahead and get started with that. Now, just for today, I'm actually, let's see, I've prepared, this is my usual scene for coding. I've actually prepared this one where I've got a nice little caveat just below my face saying this is an experiment. The reason that I put that in there is because I'm probably going to be making a lot of mistakes, and I'm also probably going to be doing things the wrong way, but I'm going to try to learn in this process. So let's have a go. All right, so the very first thing that I'm going to try out is you'll see that here inside the examples directory, there's a modified AMR volume rendering script. This is a script that Aiden has prepared, where what it does, it generates, and I haven't run this before, so let's set our expectations just a little bit. Still going. Oh, it did it just before I quit out. So this is the script, and what it's set up to do is it's set up to create a uniform grid, and then to split that uniform grid into a bajillion little pieces. Also, I just had a ginger snapped Mountain Dew. Pretty good. If you are in the chat, I've got that open, so feel free to say hello. So, what this is doing, and you'll note that it's pretty slow on my machine here, is it is taking each one of the grid objects, which in this case is probably only one or two cells, and it is uploading that as a patch, and then it is attempting to transform that into a bounding box. Now, I think what we're going to want to end up doing is we are going to want to end up transforming them, instead of into a Cartesian bounding box, into wedge-shaped objects. So transforming the left edge and the right edge into our actual spherical coordinates. Now, the funny thing about that is that in those cases, if you were to transform a proper spherical wedge spanning a dr, d theta, d phi, the left edge will include some of the next zone in the r direction, and the right edge would not include some of the next zone out. So let's see if we can instead let's see if we can first build out that triangular wedge and see if we can render just one of them. So now this is where things get to be a little bit more fun. Oh, seems that I just got notified something is on our porch. I have to tell folks that. Okay. So let's go ahead and open up in VS Code our example here. So here we've got our example AMR volume rendering. And it's breaking this into a whole bunch of little subgrids. Now I'm going to look at block collection. This is our basic object for when we render grids on the GPU. We're going to see if we can, instead of generating it from the left edges and the right edges, what I am going to do is I'm going to create a single block, which doesn't traverse very much. And I'm going to make a copy of this, so let's duplicate this. I can never remember how to do that. I'm not very good with VS Code, but it is effective for this particular use case. Let's call the spherical subset volume rendering. So here we're going to load a uniform grid. We're just going to have nprox equal to 1. And here we're going to change this. Here, let's set this to ndim equals. Let's change it down to 32. ndim. Now let's say bbox equals that. Okay. Now here, let's change this because we don't want it to subtend too much. So let's say that we want this, it goes from, let's do 0 to pi over 8. We'll do 1/8 of the domain there, 2 pi over 8. We'll do 1/8 of domain there. It's going to be one grid. Let's see what that looks like. Oh, right, I was running the wrong script. Okay, so you'll note here, it's actually rendering it, but let's take a look at this. It goes from 0 to 1, yeah, okay, so it's rendering something. Let's see if we can figure out exactly what it's doing. So let's take a look at our grid positions.vert.glsl. If it's spherical, theta equals 2, phi equals 1, v0 times sine v phi cosine v theta. Yeah, okay. So now we've got a left edge and a right edge there. I think we actually can go ahead and get rid of this. Let's do v left edge equals temp left edge. V right edge equals temp right edge. Let's save it. Now let's bring this back here, recompile our shader. That didn't do anything. No, that's not really doing it either. So let's think about this. So model vertex here. I'm not sure I know what model vertex is. The location of the vertex in model space, but I thought we had changed that. So is that giving us the grid center? Let's take a look. We need that to be the grid center. So model vertex. Data equals vert. And vert here, yeah, vert is always going to be equal to 1. So I think what we actually want to do here, VV model, that's out. GL position is projection times model view times transform vec4 model vertex. Let me take a look at what that looks like in the raw, because I don't think that's precisely what we're looking for here. But I need to verify that. So let's go back here. Let's see, GL position is model vertex. I'm actually going to, let's take a look at the PR diff. So let's take a look at this diff. And let's see where VV model equals model vertex. So why? All right, well, let's go back here. All right, let's take a look at inside our block collection. I'm actually going to do this the silly way. Import pdb, pdb.setTrace, and we'll just take a look at what vert is. All right, let's take a look at vert. Yeah, it is uniformly the same everywhere. Now, I thought for sure that that wouldn't be the case, because we've got GL position here, and GL position actually does matter for our grid position. I don't think that this gets passed through a geometry shader, but it's possible. So let's take a look here. Oh, grid expand. Expand grid left and right edges into a set of triangles. So let's take a look at grid expand.geom. Vec4 v left edge plus width times arrangement. Yeah, here's the problem. This is expanding it in Cartesian space. So what we need to do here is something similar to what we did in the other place. So over here, let's go to our grid position.vert.glsl and get rid of that thing. So here, vec3 transform vec3. Let's just go ahead and put that. So now, if it's spherical, pos is equal to transform vec3 of left edge plus width times arrangement. That should work. Let me cancel this out. Now let me go back into, let's get rid of that PDB set trace. And actually, I'm going to go ahead and I'll run the thing from in here so that I don't have to keep switching windows. Examples, spherical, subset volume rendering. Well, look at that. Okay, so that's something. Okay, now the issue that I'm seeing here is that we are centered on the wrong spot. Now, another thing that I'm kind of noticing, and I'm not totally sure, is it looks to me like this is a tetrahedron when we actually want it to be hexahedral. Not entirely sure about that, so let's take a look here. Left edge. I think we actually don't want to modify left edge at all. So here, v left edge equals in left edge. V right edge equals in right edge. VDX, yep, we got VDX. Now inside our geometry here, we go ahead and we expand it, and then we transform it. Yeah, let's try that. Okay. I think that's getting us a bit closer, but one issue to contend with now is that, is it actually hexahedral? Is we're offset. So one thing that we haven't quite dealt with in the past here is that our domain is centered at 0.5, so we're going to go ahead and offset this with plus 0.5. Let's see if that works. I can't remember if it'll do that. But that should put it into the, that was supposed to have centered it inside our domain. But it looks like it didn't, so. All right, let's get rid of our front-facing, or our culling of whatever block collection. Enable cull face. Let's actually change that to disable. So what I'm going to do right now, I'm going to do a, that didn't fix it, so I'm going to do a quick git check. that was in the wrong spot. Let me actually go back over here to grid expand. See if that rotates it into the center. No, kinda didn't, huh? We want it to be rotated. We want our focus to be, maybe we should instead just change our focus. So let's do that. Spherical subset volume rendering. Now here we've got our camera. So let's actually, I can't quite remember the specific way to do this. So let's grep cam example startup pi. So scene graph. So sg.camera.focus. Let's see if that'll do it. There we go. Now I still don't quite understand what's going on with it, but we're getting closer. So add examples, spherical volume, subset volume rendering. And now let's see, what else do we need to stage? Grid expand. Oh. Grid position. Let me go back here and take a look at that. Okay, let's try this now. So now we've reverted some of the changes. So we're just passing through the model vertex. And we're allowing our grid expansion to do all the other modifications. Now this looks a lot better. Let's see if we can actually make it so that it, let's have a radius of one, oh, you know what? That's part of the problem. The radius should be 0.5, I think. Let me quit out. But now, in principle, we should be able to have this be a subset of our wedge. Wow, that gets confusing fast. So now I think I'm seeing why we had these min and max for our left edges and right edges. But I bet if we disable our cull facing, or our face culling, we'll see a slight change there. No, not so much. Well, all right, let's get rid of that. Radius goes from 0.2 to 0.5. Okay. Getting a little bit better. Okay. So now let's go back here, and I'm going to update our, oh yeah, there we go. So nothing different about that one. Grid position, I'm going to stage that one. Okay, update to do transformations in geometry shader. Oops, ran into an error. Okay, let's. Let's do this. Update to do transformations in geometry shader. Okay. I'm going to push this. Okay. Let's go back here and let's see if we can keep figuring out what's up with this. So now, one possibility is that the way that we're setting up our left edges and right edges and all that doesn't really work with our specifics. Unable to open. Let's just close that. That's from a different branch. Now, where did my spherical subset volume rendering? This time, let's do np pi over 8 to, I guess, 2 times np dot pi over 8. And here, let's do, d 3 times np dot pi over 8. Something about the clipping is messing this up, but I actually think, you know what, it's probably not the clipping. So I have an idea of how to fix this. Let's go back here. And let's go on over into our maximum intensity. And actually, you know what, hold on. I think it's worth just having a constant color. So let's go up here. Let's see. Make a new file. And this one is going to be void main. We'll save it. Shaders constant. Wait, we already have a constant? Oh. Well, that's exactly what we need here. I'll just not save that. Okay, so let's go over here. Grid shader list. Block rendering. Ice constant. Description constant color. Grid position, grid expand, and here constant. Pass through and apply color map. Now I can't remember if it picks up all the new shaders. Let's see. Constant color. That did it. And I'm pretty sure. Okay. Yeah. Okay. Let's go ahead and what? Okay, well, it did it. So. Okay, so now we've got our thing. Now let's, this is where things get a little bit fun. So we've got our wedge. My assertion is that once we get to a particular point, it's no longer, once, and I don't remember what that point is, but it's probably about pi over 4. Once we get to that point, it's no longer going to work the way we want it to. Because our wedge will not quite do what we want. Our wedge will no longer be convex. Well, I mean, it's not convex. It's not concave now with respect to our shader, but yeah, there we go. Okay. Well, that actually gets us really far on what I wanted to accomplish today. So I think I am going to call this a day because I succeeded at what I wanted to do. So, thanks, folks. I appreciate you being here with me. We'll see what we can do next time. I'm hoping to do this again really soon.